Okay, this is Algebra 6.0. Yesterday we did graphing linear equations. Today we're graphing linear equalities. This is our 6.0 Inequalities study guide. There's a couple things I need you to remember as we're talking about inequalities. You handle an inequality very similarly to how you handle an equation. However, you have to remember when you're graphing, these two symbols tell you to use a solid line when you're graphing the equation, and these two symbols tell you to use a broken or a dotted line. And when you're graphing and you're ready to shade, if your inequality symbol is less than or equal to, you shade below the line. And if it's greater than or equal to or greater than, you shade above the line. Because remember, greater than is above the line and less than is below the line. But, this is a huge but. In order to use that trick, it must be in slope-intercept form. So if you're going to use greater than is above the line or less than is below the line, it has to be in slope-intercept form. And the other thing you need to remember when you're dealing with inequalities is the random rule. If you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. So every time you see an inequality, you have to remember all these things. All this is on a poster in our room. You should know this. Enough said. So, number one, y is less than or equal to 3x minus 4. Now the directions say graph using a function table. It's in slope-intercept form, that's fine. Function table, it says use numbers like -2, 0, and 2. It's perfectly fine if we just use those numbers. 3 random values will work. If I plug -2 into the equation, into the inequality, I'm going to get y equals 3 times -2 minus 4. Now when we're graphing inequalities, when I'm finding points, it's okay to use an equal sign in the function table. The only time I have to worry about the inequality symbol is when I'm making my line and determining if it's broken or solid, and then when I'm shading. Other than that, I'm going to treat it just like an equation. So 3 times -2 is -6, and -6 minus 4 is -10. So when x is -2, y is -10. That's my ordered pair. If you notice, that won't fit nicely on this graph, but we'll figure it out. Let's do x is 0. So y equals 3 times 0 minus 4. 3 times 0 is 0. 0 minus 4 is just minus 4. So when x is 0, y is -4. 0, comma, -4. There's my second point. And if x is 2, then y equals 3 times x minus 4. 6 minus 4 is 2. So 2 would be the last point. I'm going to graph these two first because they're easily found on my graph. 0, -4 would be 0, -1, 2, 3, 4. And 2 would be 2, 2. Now my other point is -2, -10. So it's going to be down here somewhere. Well, if I connect these first 2 points and keep going, even though it's off the graph, I can see that my third point is down here. And I think I could pretty safely say that looks like -2, -10. Can't you? I'm good with that. Oh, it's an inequality. Yikes, I made it a solid line. Oh, good. It needs to be a solid line. Whew. This tells me, this little equal sign tells me solid line. Since it's in slope-intercept form, I can use the above the line and below the line trick. Less than is below the line, baby. Oh, yeah. There's your graph. Sweet. Here's another one, and we're also going to use a function table with this one, because that's what the directions are telling me to do. So I'm going to use 3 random values. I think I'm going to rewrite this on a piece of paper so I have more room. You know how I am about these things. X is going to be, what did we decide? -2, 0, and 2. And my inequality is y is greater than -x plus 2. These are my x's. So if x is -2, this is going to be y. Remember, when we're just figuring out the points, I can use an equal sign right here. Oh, -x. Okay, x is already -2. So x is -2, but according to this, whatever x is, we have to make it more negative. So it's -2, and then we're going to add 2. Well, you know, when you're subtracting a negative, it's just like you're adding a positive. So this is actually a +2. +2 plus 2 is 4. There's my first point. If x is 0, -0 is still 0. 0 plus 2 is 2, so y equals 2 when x is 0. If x is +2, then y equals negative whatever x is. We're going to make it negative. X is +2, so we're going to take +2 and we're going to make it negative. And then we're going to add 2. -2 plus 2 is 0. So my 3 points are -2, 4, -2, 4, 0, 2, 0, 2, and 2, 0. Are those 3 points in a straight line? I believe that they are. Oh, it's an inequality. Hold the phone. This tells me no solid line because there's no equals, so it's going to be broken or dotted. And since it's in slope-intercept form, I can say that greater than is above the line. There we are. Broken line, shaded above, and I can say that because greater than is above the line when it's in slope-intercept form, which it is. Okay? Next one. 3x minus 2y is greater than 15. We did this in class, and it says graph using an x and y intercept. We're going to make x 0. So 3x would be 3 times 0, which would just be 0. There's that tricky negative. Negative 2y equals 15. I can say equals because we're only working on the point right now. We're not figuring out the line or shading. We're going to divide by -2 on both sides. This is 1 whole. 1 times y is y. And 15 divided by 2 is 7.5. And a positive divided by a negative is a negative. If you want, you can call it 7.5. Okay. Now, we're going to make y 0 to find our x-intercept. So if y is 0, that means -2 times 0 is 0. 3x minus nothing is 3x. 3x equals 15. Divide both sides by 3. X equals 5. So our 2 points are 0, negative 7.5. So we have 0, negative 1, 2, 3, 4, 5, 6, 7.5 would just probably be about right there. And then our other point was 5, 0. X is 5. Y is 0. Since it is greater than, and there's no equal sign, it's a broken line, but hold it, I got to shade it, and it's not in slope-intercept form. So I got to put it in slope-intercept form so my little trick works. So I'm going to get negative 2y alone. It's an inequality, so I'm going to do my fish hooks and my inequality symbol, and I'm going to remember my random rule. And if I want negative 2y alone, I'm going to subtract 3x from both sides. And I'm going to get, these cancel out, I'm left with negative 2y is greater than, I have two terms over here. I have a negative 3x and I have a positive 15. I need to get y alone, so I'm going to divide every stinking term by negative 2. There's one whole times y is y. Negative 3 divided by negative 2 is a positive 3 over 2 x minus 7.5. Okay, but look, I divided everything by a negative 2. I have to flip my inequality symbol, so it's less than. So I've already graphed it. I graphed it using my x and y intercepts. I just flipped it so I'd know for sure where to shade it, and this says less than, so it's below the line. If I had shaded it using this, we would have been above the line, but it's not in slope-intercept form. When I put it in slope-intercept form, I have to flip my symbol, and now it's less than, so we shade below the line. It's a good thing we put it in slope-intercept form. Okay, next video we're going to start with number 4.